I will explain now design of single cross-section using the tables. So this is the second part of chapter number 5, and I'm giving you here one example how to design rectangular sections for the beam, load, and reinforcement ratio values shown. Beam weights are not included in the load shown. Show sketches of cross-sections including bar sizes, arrangements, and spacing, and assume concrete weighs 150 pound per cubic feet. Your yielding stress is 60,000 psi and compressive strength of concrete is 4,000 psi unless given otherwise. What we have here is simply supported beam subjected to distributed load, that is the dead load of 1.5 kg per feet, and you have 2 live load forces of 20 kips. The distance is 10 feet from the supports. In this problem, it states that reinforcement ratio is equal 0.18 times compressive strength of concrete over yielding stress. And if we plug our numbers, it will be 0.18 times 4 over 60, which will give us the value of 0.0120. What we have here, we need to draw the moment diagrams using the 2-point forces and distributed load. Since that we have point forces as a live load, we need to multiply with 1.6, which will be safety factor, and our moment, the maximum moment, will be 320 kip feet. This is moment maximum due to live load. Regarding to the dead load, we have 1.5 kg per feet, and we are assuming self-weight. In our case, let's assume 50 pound per feet. So the total dead load will be 2 pound per kip feet. And when we multiply with safety factor for a dead load, which is 1.2, we will have 2.4 kg per feet. So maximum moment due to dead load will be QL square over 8, which is 270 kip per feet. So the total moment due to external loads is 590 kip per feet. So we are adding the live load, which is 320, and we have dead load, which is 270. So the total moment due to external load is 590 kip per feet. Since that reinforcement ratio is given, and see, we have 0.0120, the ratio mu over phi bd square is equal 643.5. So this is the table 813 for our yielding stress of 60,000 psi, and we have compressive strength of 4,000 psi. In AC handouts, you have more tables with a different yielding stress and different compressive stress. So in your problems, when reinforcement ratio is given, you can just read how much is mu over phi bd square. Since that in our case with reinforcement ratio of 0.0120, you have mu over phi bd square to be equal 643.5. So what we have already determined how much is external moment. So it's 590. We need to multiply with 12 to get kip per inch, and to multiply with 1000 to get pound inch moment. So over 0.9, which we are assuming that tension controls in this case, and we have BD square. In our cases for B, we are using approximately 0.7 times D. So we can use instead of B 0.7 times D, and we have D square to be equal 643.5. Solving this equation for D, we will get that minimum depth is 25.94 inch. So I'm assuming that D is equal 26 inch. For concrete cover, the minimum for B is 1.5. So let's say that we have 2 inch. So the total height will be 28 inch. For B, we said 0.7 times D, so 0.7 times 26 inch will give me the width of the cross section to be 18 inch. So my cross section in our case is 18 times 26. So B times D will be 18 times 26. Since that I already have reinforcement ratio to be equal 0.0120, And I explained in the previous video that reinforcement ratio is still area over B times D. In our case, reinforcement will be 5.62 inch square. So now I can pick 5 number 9, but you don't have to pick 5 number 9. You can pick something number 10 or number 11 rebars. In this case, I have 5 number 9, which will give me 5.64 inch square. So this is now my cross section, 5 number 9 with width of 18 and the height of 28 inch. So what I have to do next? Now I need to realize how much really I have dead load. So I have 150 pound per cubic feet for a weight of concrete times 28 times 18 over 154, which will give me 525 pounds per feet. And my total dead load now will be 2.025 times 1.2, which is 2.43 key per feet. And the maximum now is 243 times 30 square over 8, which is 273 key per feet. When I add my live load, I will get the total load of 573 kip per feet, which is 6,876 kip per inch. Now we are going back. We need to determine how much is moment strength capacity just to realize if our cross section can handle the external load. So what we have 5 number 9. We can get how much is tensile force multiplying the area of steel with yielding stress. So in our case, that is 338 kip. We can determine how much is straining steel using the equation that straining concrete times the D minus C over C. So we need to find how much is the depth of the witness block. Again, I gave you this equation earlier. You have area of steel over 0.85 over times FC prime times B. So in our case, you will get something which is 564 times 60 over 0.85 times 4 times 18 to be equal 5.52 inch. So that is the depth of the witness block, and your location of neutral axis will be the depth of the witness block over beta 1, in our case that is 0.85. So you will get that location of neutral axis is 6.5 inch. Now, when we plug our numbers in the strain of steel, you will get the strain to be 0.009, which means that tension controls, so strength reduction factor will be 0.9. So now we are using the equation for a moment strength capacity, which is tensile force times the lever arm. So 338 kip times 26 minus 5.52 over 2 will give me 8,552 kip per inch. And if I multiply that with strength reduction factor and to divide by 12, you will get the moment strength capacity to be equal 641.4 kip feet, which is higher than our external load. So this will be the procedure how to design cross section when reinforcement ratio is given. Thank you.